Yo, yo, yo. Hello, everyone. Yeah, another stream today. We'll continue our journey on LeetCode.io. So, solving like arrays and hashing problems. We had a lot of troubles last time with this one, product array except the self. This one will not be able to solve because I'll need premium, unfortunately, but I have an impression that I did solve something like this in my library of problems solved. But for today, we'll be focusing on this longest consecutive sequence. So we'll be finishing this one, and we'll start with 2 pointers, and if we'll manage to solve everything, likely or unlikely, we'll see how far we'll manage to get. But we'll solve this list, and later on we'll move to stack, binary search, sliding window, linked list, trees, and so on. So for now, let's dive into the longest consecutive sequence. That would be the problem which we'll be solving. So it looks like I have it opened here. Let me zoom it a bit. This is a tricky problem. If you don't know how exactly to solve it, this may create some difficulties, because you'll need to think outside of the box to manage to solve it. Yeah, let me check if everything's in norm. The stream looks up and running. So yeah, I advance a bit. So I have a streak of 71 days of solving LeetCode problems. Biggest so far. So I saw, yeah, Unwarekare joined even before the stream. So greetings and shout outs. Yeah, so let's read what this problem wants from us. So it's the longest consecutive sequence. Given an unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in big O of n time. So let's look at a couple of examples. First one being, we have like nums starting 100, 4, 200, 1, 3, and 2. As we can see here, the longest consecutive sequence would be 4 items, like 1, 2, 3, 4. So this is quite tricky to solve. Let's check our drawing board and try to work out these two examples, because to be honest, without a trick, because I did a little bit of investigation before, this would take me a lot of time, and I'm not sure if I would come to the solution. But knowing the trick, this would be an easy solution. Okay, I feel like, sorry about that. I feel like I need to reduce a bit the music. It's too loud for me. I can't concentrate. Okay, so we have our example. So the trick here is we'll need to write an algorithm in big O of n time, which this is the trickiest part, because if we want to find the longest consecutive, let's say the length of the longest consecutive sequence, simplest and most trivial approach would be we sort the array. So we have like a 1, 2, 3, 4, then 100, then 200, and we can go item by item. If the second is part of a sequence, third, and so on. so we can find easily what would be the sequence. So this would be one sequence, this would be another sequence, the third one would be another sequence. So if we sort the array, in this case, our algorithm will be like big O of n log n, which will be a very slow algorithm for this problem. So how can we manage to solve it in big O of n? Yeah, so for this we'll need to know the trick. The trick is, in order to find the sequence, so let's imagine, I'm not sure that would be the best way to describe it, but we'll need to find what would be the starts of the sequence. So let's imagine 100. We go, if the solution hints us, we'll need to use just a linear approach. Then we'll need to go item by item. So let's pick first 100. Does 100 start a sequence, or is in the middle of a sequence, or it's the end of the sequence? How can we know? So yeah, if you want to know if 100 is in the middle, then probably the best way it's to check if there is a previous element like 99, or there is 101, to check somewhere if those items are in our array. And this, it's a little bit tricky because we cannot like iterate for our array multiple times, so we cannot use like searches and finds. So this hints us to use a different data structures called a hash set. So we'll transform our input nums first, and we'll transform it into a hash set. And what this will allow us, to check if some specific items are in our set in constant time of 1. So imagine we have 100. Then, if we have 100, if 100 is a start of a sequence, then this means 99 should not exist in our set. And we can easily check if 99 exists in our set or not. And then, if you want to see how big is the sequence, we can start creating a range, an infinite range, let's put it, and check if the next item in our sequence exists in our set. So we'll need to check if 101 exists in our hash set, and it does not. So this means we have like a start of a sequence, and the sequence being length 1. So that's the trick. I did not think of going this direction, to be honest. So the trick with the hash set, it's a really cool one. So yeah, I guess now what we'll need to do, first stage, transform our array in a hash set. Go item by item using a for loop of nums. Check if it's our item, it's the start of the sequence or not. If it's not a start of a sequence, we don't care, because we'll need to check only if it's a start of the sequence. So we'll be checking if our nums, this will be nums. Simplest way will be like item -1. It's not contained in hash set. It's not in set. If it's not in set, this means item, it's a start of the sequence. Then we'll start using a while loop. We increase our number till there is no more item in our hash set, and that will be our length, or our length of the sequence. And we'll need as well to have a max length somewhere above, because we may have multiple sequences, but we'll need the biggest one. So we'll update the max length and we'll be returning the max length. And yeah, so we'll be coding this part. This is like a very rough pseudocode. Okay, so we'll be coding this one. So let's check first what will be the time complexity and space complexity of this algorithm. So time complexity, what do we have? First, we'll need to do the hash set. So we'll need to iterate our nums n time. Then we have this for loop. Then we'll have this length part, which may seem that this worst case scenario will be like n square, which probably it is for the worst case scenario. When, for example, but not necessarily, because we may do an optimization later on. Because imagine we have such a sequence where we have like everything written backwards. We have like 9, 8, 7, 6, 5, 4, 3, 2, 1. Yeah, actually in this case, how the algorithm will work, 9 will be considered start of the sequence. But actually no, because 9 will not be a start of the sequence. Because we have 8 in our set, and minus 1, this part, and minus 1. So we'll be moving to the next one. 8 is not, so we're moving to this one, is not, this one not, this one not. So we'll move towards D1. 1 will be the start of the sequence, because 0, it's not in our set. And then we start this while loop, and again checking if all those items are there. So pretty much we'll be traversing all items once, and at worst case we'll need to check the second time if all the items are there. So I guess the complexity would be like not n square, that's a mistake, it will be like 2n. Even though it's written in such a form that at high level you may see it as n square. So still, if we sum all the parts together, we'll have time complexity being big O of n, and space complexity, because we'll need this extra hash set and a couple of variables, big O of n as well. So yeah, let's start coding it. I feel like we played around quite well for now. Okay, so we are here. Let's create this one. Cargo new longest consecutive sequence number 128, and this would be a lib. So let's open this part. Okay. We know the drill. We'll need to create a struct solution. Then let me copy this part. I'll be adding a to-do here for this to compile, and let me add a couple of scenarios. So this would be a vector, this will be a number. So 104, okay, so 100, 4, 200, 1, 3, 2. I guess it doesn't matter the order. And here I'll have a solution, longest consecutive input. So yeah, let's start implementing our algorithm. So we have our hash set. Let's call it hash set. So we'll have like nums, iterator, collect, hash set of i32s. Yeah, we'll need to include this. I feel like it will not allow us because we kind of need to make it as references. Okay, let me call it just set. We'll not mutate it, so let it be just like this for now. Yeah, we'll need like max sequence plan. Let's go with 0 at first. Next stage we'll do our for loop for like n and nums. We'll need to iterate through our numbers. Yeah, we'll be returning this max sequence. So yeah, probably let me call this num. Now we'll need to check if this is the start of a sequence, and for that we'll use set contains num -1. Actually, it doesn't contain, so we need to check if this stuff it's not in the set. If it's not in the set, then this would be the start of the sequence. So start of this sequence. Looks like I cannot move out the nums because it's borrowed. Move out the nums occurs where? Here maybe? Okay, I guess let's use it as a reference and don't care much. Yeah, maybe we'll need to go this way. Yeah, we'll need to consider borrowing. So yeah, let me consider that. So this would be the start of the sequence. Then let's have a mutable variable like sequence length. Start at 0 and then have like a copy of our number. Let mutable tmp will be our num, because that would be, yeah, actually we have our first number, so the sequence length will be 1, not 0 in this case. So we have our num, and now what we need to do, while I guess the most idiomatic way to do it in Rust would be to do something like let's sum. Okay, maybe let it be num again. Where we do here set contains. Yeah, well, actually it will not be like this, but it will be like while set contains num +1. Yeah, we'll need to, and this is not JavaScript, you'll need to make sure that this is true. While this is going up, we'll have like sequence length plus equal 1. And actually here it will be like tmp. And tmp plus equal 1 as well. I guess we'll need to do it like this. It looks like it doesn't like. Okay, how about that? Yeah, okay, so how about this? And then we'll not need this. So we'll have this sequence. if this is not true, then we will need to update our sequence length. So max sequence will be max sequence len, max, and our sequence length. So that's all the needed code. Start of this sequence. Yeah, let me check. Let me try to run this and see if this works. Yeah, it does work. In this case, let's check the second one. Let me check the second one. So yeah, hash sets in this case helped a ton. Yeah, both of them are just working fine. So we have our solution. Let's copy it and try to run on LeetCode. We'll not need this part. And let's run the next one. Runtime. So yeah, looks like we have a solution, but the runtime, it's far from being like a fast one. So I guess now it's time to check other solutions. So let's look at the winners. Okay. Yeah, I really don't get it. How a sorting solution, it's faster than this one. No, something is not right. Okay, so hash set from this. If set contains n minus 1, this is exactly my solution. Exactly. I mean, yeah, I don't understand. Yeah, probably it's I think what's the trouble here, because yeah, next solution, all of them are the same. I think like this results are when they just added the problem, like 10 microseconds. After that, they started to add more test cases and unit tests, test scenarios, bigger ones, and I feel like all solution got into this range. Because this is for sure not faster. I mean, I can give it a try. I'm pretty sure that this will not even pass now. So let me try to submit this. No, it is the fastest. Wait, either it's some sort of caching. I feel like some sort of caching there. Okay, it's super weird. And yeah, highly unclear. I cannot explain this. How a sorting algorithm is faster than a linear one. Or is it linear though? Let me check again. Maybe I'm... So we have this for loop and we have this while loop. So yeah, I guess for some cases, if you have like let's say a million or so of items, yeah, we'll need to optimize this, because if we saw the number once, then maybe it doesn't make sense for us to check it again. So maybe we should spend a bit more memory. Yeah, let me move it back, because I'll go with a solution now. Because if I counted it once, so maybe we can add another set. I'll call it scene, which will be a hash set new. And I'll be checking if scene contains none. Then we will just continue. What's the problem? Yeah, it doesn't know now what's is here. Here at this stage, I'll do like a scene insert TMP. So yeah, we'll be duplicating the memory, but we'll be skipping the numbers already seen. So we'll not double count them. We'll not do this weird for loop, because if we counted it into a sequence, wait a second. Is it mentioned somewhere if this is a distinct? Yeah, but it doesn't matter in this case if it's distinct or not. Yeah, I'm not sure. Not sure if that's the right solution though. I feel like it will not make things worse. Maybe it will make it a little bit faster. But for some test cases it may not work. Oh, so it looks like it doesn't work right now for this case. Yeah, I feel like this is why the solution with yeah, because we have duplicates, and some of the zero will need to participate inside. Okay, let it be. Let it be for now. Let's leave it as it is. Yeah, maybe the case for sorting, it's faster. But that's extremely weird scenario. But anyway, okay, whatever. Let's submit again and move on. Map set. So map set. Yeah, we have different kind of other solutions here. I'm trying to check. Yeah, visited or seen. Yeah, this is the approach which I wanna go. So yeah, maybe I nums into iterator, set get nums -1, continue, visited contains num continue. Yeah, that's the micro optimization which I did, but it doesn't work for me. So it looks like I've missed some cases. Yeah, and that's initially what I wanted to do with some I, but it's same principle. Okay, I mean, principle is the same, but this uh, weird execution time, it's interesting to see. Anyway, okay, let's finish this one and let's mark this one as done. And we are done with arrays and hashing. I have one in the list. Unfortunately, I need to buy premium, and I'll do one day. I'll buy premium for LeetCode. Yeah, let's check the 2 pointers. So we have a new group of problems called valid palindrome. Okay, so a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. A man, a plan, a canal. A man, a plan, and a canal. Race a car. Okay, that's a cool one. And we'll need to apply the 2 pointers technique. So yeah, let's start writing the code for this one. So first, I guess we'll play around a bit on our whiteboard and outline the algorithm. So we'll not need this one. So well, we do have a string. Yeah, we do have a string. We'll need to do a couple of manipulation to this string, and first kind of will need to transform all uppercase letters in lowercase letters. We'll need to strip and remove any letter which is not alphabetic. So everything non-alphabetic needs to go. And then the result, for this case, it will be a man, a plan, a canal. Canal, okay. And Panama. So once we've got to this stage, once we got to this stage, we can have like 2 pointers, one above, one below, and start comparing all the items. So like this will be like left, right, and we go one by one. If left is equal to right, then we do left plus equal 1 and right plus equal 1. Right actually will decrement, minus equal 1. So pretty straightforward. So we'll do this till, so we'll have like a while loop. While left is smaller or equal than right, because they will need to either, if it's an odd lang, they will not meet. If it's an even length, they will meet somewhere in between, in the middle. And else, for this case, if at least one is not right, then this is not a palindrome and we will return false. Return false. So yeah, it's a quite easy, straightforward problem. We'll have a little bit of work to do with the manipulations here. With the transformation part, but I think it's pretty straightforward overall. Yeah, let's create another problem. So it's called valid palindrome. I have an impression I did this one. Okay, so no, actually I did not. Yeah, I did so many other problems, but so it's 125. This should be a lib. Okay, let me zoom it. Let's copy the interface. And let's add a couple of scenarios. So I'll be copying this one. Okay, copy 2 times. Yeah, let's add the second one. I guess it will be like race a car. Yeah, I was checking why this is not a palindrome, but it's not. Because we have like race, but here in the middle we have E and A. So false. Yeah, palindrome problems are very common in school Olympiads. Or I guess in competitive programming at all levels, you'll find them. But to be honest, I never ever managed to have like a real work problem concerning a palindrome or prime numbers. So yeah, that's quite interesting. Okay, so we do have our inputs. Let's start implementing them. So first stage, we'll do the cleanup. So we'll be filtering out all. So we'll have characters. So GH is alphabetic. I feel like this will filter out absolutely all lowercase. Will fill out all. Will filter out all weird signs like empty spaces, commas, 2 points, and so on. But I guess next stage, what we'll need to do is to map GH. So we'll need to map to make it lowercase to lowercase, I guess. But actually, maybe the reason we'll be able to use a filter map to do it in one go. So filter map, GH. Yeah, but every time I forget what's the idea with the filter map. Okay, so we have like a filter, it's okay, a map as unwrap. Not sure if that's the case though. So what I want to do, okay, so we have like 1, 2, not a number, 4 and 5. So filter map pause and okay. I guess. Let me check. Yeah, we will see. Yeah, okay, so let's go simple for now. So we have like this, we have this, and we'll be receiving an iterator. I guess with 2 pointers, there are a couple of options, but I can do it with the with iterators a bit using some sort of next level techniques. So we'll have like a iterator, and here I'll have like 2 iterators. So I'll have like first, let me call GHS. So I'll put it this way. So I'll have GHS, and then I'll do a zip, and I'll do GHS iterator, but this is already in this form, so I'll be zipping this, and then I'll do all, and I'll have like A and B, and I'll need to make sure that A and B are equal. Binary operation. Oh, wait. A equal B. Let's go this way. Yeah, kind of that's the trick, as we need to clone it somehow. Cloned. Yeah. So it's the same approach with 2 pointers, but unfortunately here I feel like we'll use a bit more memory than needed, because that's exactly the same implementation, but I'm not sure if that's the case. Here I may have troubles with the internals of Rust, because I'm not collecting it into a vector. But I guess we can try. We can try and see which one will consume more memory. This approach, we're like collecting it and then having like 2 pointers. Because I'm feeling like this still some sort of needs to be collected somewhere if you do this clone part. Yeah, let's give it a shot and see which approach will be faster. So first, let's check if this compiles. Yeah, and another thing I wanted to do, it's so yeah, let's submit. 0p true. Expected false. Wait a second. So why this is expected false? I don't really get it. So 0, it's not an alphabetic number, so it will remain only p, lowercase p. So p, it's a palindrome. not sure I understand this. Why this should be true or false? Yeah, let me read a bit. Okay, so yeah, let's check discussion. One of the test cases seems to be wrong. Okay, so yeah, that's my case. Why a dot A returns true and OP returns false? Thanks for explaining it. Alphanumeric. Oh, it's not alphabetic, it's alphanumeric. So numbers will remain the same. Alphanumeric characters include letters and... Oh my god, I didn't read it. So yeah, it's clear now. So it's alphanumeric. Okay, so yeah, that's clear. I guess we can run cargo clippy to see what else can we improve, and we cannot improve anything special right now. So yeah, let's run this pod. So first thing we'll do this and compare now. I want to see the memory usage. Okay, so it does work. So memory actually is pretty good, though time is not that good. But I assume for millisecond it's quite good result. Let's see other solutions. Collect. Okay, so this is the other approach I wanted to go. Looks like that one would be faster. I don't know. Yeah, this is less code. One perspective. But yeah, still, let's first check. So we have like 2.33 megabytes, but I guess it will be quite... okay, so let's collect. So we have our chars. So here I'll be collecting my chars. Lack of char. What's wrong? Yeah, looks like true for now. To lowercase. Wait a second. To string, I guess. Okay, so in either form, I guess we can collect it as string. We cannot collect it as string. Wait, so we do to lowercase and then to string. And then this will be able, then we'll manage to collect it as string. We call it cleaned. Yeah, the solution became completely different. But, okay, so we have like left. Start at 0, let equal right, start at lint.len -1. While left smaller or equal than right. We do f yeah, I don't think this will work though, because with strings in Rust, things are a bit more complex. Yeah, this will not expected bool. Okay, so let me do here for this to compile. By use size. Yeah, here we'll need to do some weird manipulation like this. Because we'll need to check the reference part. I guess we can do this. If it's not, then actually, yeah, let's keep it like this. We'll do left plus equal 1, right minus equal 1, and else we'll be returning false right away. And here we'll be returning true. So this should work as well. Yeah, indeed it does. Let's check this solution over the previous. And hope that this will use less memory, which I highly doubt. Yeah, for empty string. Yeah, this is the stuff which I don't like, as for empty string, it will be cleaned up and cleaned will be 0. And this stuff will be minus 1. So I guess we'll need to write somewhere here. If cleaned is empty, return true. So that's another weird hack, which I need to do in order for this to compile and work properly. So yeah, it's too much code for such a small improvement. And I'm not sure if RAM will be even less. Runtime error for A. So what happens if it's 1? Okay, left 0, right, it's also 0. So we'll have this stuff. Yeah. So yeah, that's the annoying part when you do this two pointers operation. When they intersect in Rust, you'll have troubles. Okay, let me use this test case. So yeah, the other approach is by far more convenient, at least for me. Even if it uses a tiny bit more memory, I will not need to. Yeah, I mean, yeah, actually it's comparable. Yeah, the previous approach, yeah, I don't even know what this stuff does. It looks weird. I would trade off my previous implementation over this. Yeah, so my assumption was correct. Looks like this approach uses a bit less memory than the previous. like point, it was 2.33 if I'm not mistaken. So time wise it's exactly the same, but a little bit less memory this one. But I don't like it. It's too complex, ugly, annoying with these 2 pointers. So I'll go back and leave it. Yeah, maybe there is another way on how we can do this. Yeah. So all the memory, I have assumption that it's here. When we do the zipping part, and then we do the comparison like this A and B, so it's very clean solution. So I would maintain this one over the previous with the weird pointers. Conceptually it's similar, but this one I like more. So let me push this one. It's way less code. So I do 2 iterators here, one in one direction, the second in the second direction, and then I'll do the comparison. So that's the whole algorithm here. So let me submit this. Okay, I have no clue. I guess it was random because looks like now we are first on both time and memory. So I guess it's random still. The 0 microseconds, 1 microsecond. Usually the leaders, so yeah, way less memory this time. Okay, I guess we are done with this one. We found a very nice way on how to implement it. I like it. I like this this solution. Let's mark this as done, and let's move on. Maybe we'll manage to solve this one as well today. To sum 2. Input array is sorted. I think we solved to sum 1, if I'm not mistaken. Yeah, let's see. Given a 1-indexed array of integers numbers that is already sorted in non-decreasing order. Okay, so it's in an increasing order. Find 2 numbers such that they add up to a specific target number. Let these 2 numbers be numbers index I and numbers index 2, where I is less or equal than index 1 and is strictly less than index 2. This means it's not the same number, written in a very weird manner, but math guys, they are weird. Return the indices of the 2 numbers, index 1 and index 2, added by 1 as an integer array, index 1 and index 2 of length 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Constant extra space. Oh, so that's the trick. Because if you recall, I solved this problem. I don't know exactly in what stream, but I remember solving it. And we used a hash set to store the complements. But to store the complements in a hash set, we'll be using an extra time, not extra time, but we'll be using just big O of n space, but we are not allowed to do that anymore. So our previous solution was still big O of n time, but as well big O of n space. But they do not allow us now to use big O of n space or no extra space. This means we can use constant space. This means we are able to use like variables, constants, and constant space. Yeah, that in general will what it will mean. So we know that our vector is sorted, which previously it was not the case. Previously we didn't know this. So we have like a new constraint that our vector is sorted. So I guess now the solution is as well our 2 pointers, like 2, 7, 11, and 15. And I think I had someone during the stream which mentioned this 2-pointer technique, and I've even mentioned why it's not possible because it's not sorted. Because if I start with left and right 2 pointers, the problem is quite easy now. So we have target being 9, because we do the following. So we start with 2 and right being 15. So we do the sum, left plus right, and we do a comparison with 9. So in this case we have like 17, because it's 2 and 15. So we see that 17 is strictly greater than 9. This means we should move right a position on the left. Just a moment. Okay. So we'll be moving right a position left on the left side. So we will do right minus minus, and the next stage we'll have like left being 2 and right being 11. So we'll do this sum. It will be 13 in this case, as well strictly greater than 9, and this implies that we'll move right even more on the left. So we'll have like 9, which will be exactly our position, and now we'll have our indexes, because we know left it's at index 0 and the right at index 1. So we'll be returning this this result. If for example we had something different, so probably let me copy a different example. So let's check. Yeah, maybe this one will work. Yeah, this one, I think this one will work. No, actually this one will find the solution right away. This one as well will find right away with 2 pointers. I want some example where we'll be moving the index on the right side a bit, and I think I can engineer it in this form. So let it be like 1, 2, 7, 11, and 15. So, and similar target being 9. So I'll have here being left pointer, and here being the right pointer. So first we'll have 16, we move on the right, it will be here. Second will be like 12, we move even less, and at this stage we have 8. 8 is less than 9. This implies we'll need to increment L, so move left, right. So left will be at this stage, and finally we've got 9 equal 9. So in theory this solution should work. Let's try to code it. Okay, so let me remove this. So spend some time to create it. To sum 2. Okay, so cargo new to sums array sorted and number 167. Okay, so let's add our scenarios. And we'll be returning another vector. Yeah, I'll need to create my struct. So, usual stuff. I'm just preparing my test cases. What's the trouble? Yeah, I'll need a target as well. So here we'll have the nums part and we need a target. So it will be like 2, 7, 11, 13. And result will be like 1 and 2. Here we'll need to destructure this. So it will be like nums and target. Nums and target. So yeah, we added our test case. It does compile, but it's not implemented yet. Okay. We start with our pointers, which will be numbers of len -1. Yeah, and we'll need to make sure that all those operations are correct. Because we are not allowed with usize, we are not allowed to go negative. So Rust, it's picky with this kind of subtractions. But the skeleton of the algorithm will be exactly the same always. So we'll checking these 2 pointers left and right. They need to meet each other somewhere in the middle. And we do like f numbers left plus numbers right is strictly greater than target. We know that we'll need to reduce right. Else if numbers left plus numbers right is strictly less than target, then we need to increment our left pointer. But here we may have troubles going negative, and we'll do if right is 0, we break. What else? And else we break again. If this operation is exactly target, then we break again. So the result will be like back, left +1, right +1. But they need to be I32s. So another small moment important in Rust. need to convert the types. So yeah, let's give it a shot. It did work. Yeah, we'll probably need to add a couple of scenarios with is there anything with one number only? Oh, so they mentioned that the tests are generated such that there is exactly one solution. So there should be a solution. So we shouldn't bother on checking if it's only one number or two numbers. So yeah, let's check this example with odd number of numbers. So I think it's 6, and the result will be 1 and 3. So run this, it works. Okay, I guess that's the solution. So it was a medium one, but using these 2-pointer techniques, I can tell that for sure I solved easy problems way harder than this one. So that's not sure if it's accurately it's an accurate easy problem. Maybe it should be a medium. Okay, so memory wise, do we use anything extra? Actually we don't. Nothing extra, but looks like no one else is using anything extra, so this is why the memory part it's quite low, but also it's quite random, this part. If I run it multiple times, I may get better memory, or I can get lower time. Yeah, you see. So you run it a couple more times and you'll get better results, because this is a bit random. But algorithm wise, this is yeah, pretty straightforward. A little bit of annoying checks here. This one to not go in minus, but nothing critical other than that. 2 pointers technique. We solved this one. Free sum. Okay, so looks like we have a free sum. So I have an assumption that this is similar but with 3. Now looks like it's a different problem. But it has a funny name, like a free sum. Always inspiring. So let's check. Given an integer array nums, return all the triplets nums I, nums j, nums k, such that I is not equal j, I is not equal k, and j is not equal k. So they should be different, all of them. And nums I plus num j plus num k will be equaling 0. Notice that the solution set must not contain duplicate triplets. So here we have like 4 triplets. Actually 2 triplets. Wait, why only 2 and not 4? So, or the order it's yeah, I guess no. So explanation, nums 0 plus nums 1 and nums 2 minus 1 plus 0. Okay, so this is 0. Nums 1 plus nums 2 plus nums 4. Nums 1, nums 2 plus nums 4. What? Oh, this would be nums 4. Okay, yeah. This will be 0. But this first and second distinct triplets are, notice that the order of the output and the order of the triplets does not matter. Okay, so they need to be distinct, but not necessarily. Oh, that's a cool one. So we do have like 3,000 of those, and they range between minus 10,000 and 10,000. So yeah, let's check. So we have arrays sorting. They hint us to sort. So we essentially need to find three numbers, x, y, z, in such that they add up to the given value. If we fix one of the numbers, say x, we are left with two-sum problem at hand. And we solved two-sum problem. Okay, so in previous example, we did solve the two-sum problem. Okay, for the two-sum problem, if we fix one of the numbers, say x, we have to scan the entire array to find the next number, y, which is value minus x. Can we change our array somehow so that the search becomes faster? Yeah, I mean, they want to hint us that we can sort it. The second train of thought for two-sum is without changing the array. Can we use additional space somehow? Yeah, so here they hint us on using a set. Like maybe a hash map. Maybe a hash map to use a hash set. Yeah, a hash map would indeed help us. So if we fix, for example, minus 1, then in outside items, we'll need to find a two-sum. Which the result will be opposite of this one. Okay. Yeah, this is a bit more complex and builds up on the previous example. Builds up on the previous example. Though the trick here I feel like still we'll need to sort it somehow, because it's getting very, very tricky. If we don't do it. So yeah, let's move to our whiteboard. I think that would be the last one for today. If we'll manage to solve this one, but first stage I feel like we'll sort it. Maybe we'll optimize it later on. But yeah, hints are pretty good. Yeah, let's first add it here, and then we'll I guess we'll resum. We'll go to our whiteboard. So this is the number 15. So one of the first problems added to LeetCode. Now let me zoom it. Add this part. Struct solution, and here let's do it to do for now. Let's add a couple of scenarios. Unfortunately, with this kind of problems, it would be a bit tricky to test equality of vectors, because we may have troubles with order, but I guess we will engineer them to just be fine in the end. I just need it set up to be able to use the debugger if I'll need it, and do different other tricks, operations. Useful to resolve this problem. Okay, so we do have this solution, and we have the free sum, we have our vector, we have our scenarios. What's wrong? I guess it doesn't know what type is this. And expected, yeah, actually this should be a back of 1. Go, go, go. Yeah, hello. Actually, you're a bit late today, but I managed to solve a couple of problems. I'm not sure, like 2, 3 of them. Yeah, let me check. Yeah, I've managed to solve 3 problems, like valid palindrome, 2 sum 2, and we solved this one here, longest consecutive sequence. So 3 problems solved, and working on the 4th one. And this one, it's a cool one. So we'll need to find triplets in a specific nums vector, such that all the numbers there in sum will give us 0. Today I'm late. Yeah, a bit late, but nonetheless, thank you for coming. So I saw you wrote in the chat, yo. I thought you were there, or probably you wrote it in the morning or something. Let me type one example. Yeah, I'm getting in a circle shape or a sphere shape. Yeah, I have like some days my mind is out, other days works a bit better. But yeah, we just need to train. So this is hey, we're driving. Oh, okay, cool. No worries, no worries. No harm done. So this is a kind of a multi-layered problem, and funniest thing that I've solved kind of all layers. So I have all the bricks. Now what I'll need to do is kind of design an algorithm which will be easy, fast to implement. And let's play a bit on our whiteboard. So first thing, I guess, first way or first moment which I can start doing, it's to sort this one. Because if I sort it, we just finished solving the problem, how it's called, like two sum, and this will be like a free sum. So if we sort it, we'll have like -1, -1 again. Oh, actually, no. It'll be like -4, -1, 0, no, 1 more, -1. Then we have 0, 1, and 2. So we have this this num sorted. Now, next stage, I can go number by number. Like for example, I'll start with 4. With -4. So this will be my picked number. So in the remaining array vector, I'll need to search, or I'll need to apply my toSum algorithm, which I've just added, to find the target to be 4, because in sum, both of them needs to be like 0. So I have -4 being the first, or 4 being the second. So what will be the algorithm in this case? What will be the algorithm in this case? So we will have the sorting part will be big O of n log n. Then we'll have a AND loop for each number. Then inside we'll have an AND for the toSum part. These two will multiply and we'll have a big O of n square. So our algorithm in this case will be big O of n square, and we will not need extra space. Will not need extra space. So that would be one approach of solving this problem, being n square. But knowing LeetCode, I don't think this will pass though. Or will it pass? Yeah, I feel like we need to find something better. But can we? Can we find something better? Because we have the other option to not sort it and find the toSum part with the complement using the hash set strategy or the hash map, wherever. So we'll be using more memory, but this will be like big O of n. But still, I mean, still we'll need to do for each like n operator. No, I feel like it's too complex. Yeah, maybe this will do like first implementation. I'll go with this approach, sorting, then going one item, and finding the toSum, and then getting the result. Yeah, hash maps everywhere. Yeah, I mean, hash maps are like, who invented the hash maps? We should create a statue. Because really, it's most common, most useful data structure in computer science. I cannot think of something better and more frequently used. I guess it's not used enough because there are many engineers which they don't care about time complexity. Their argument is always, okay, so what's the point? It's we have just a small amount of data, so we don't care about, because it's, instead of they just use collection find and collection.find, and they do their search part, getting the result, which will be like big O of n. Instead of storing that collection into a hash map and getting the result in constant time, because memory wise very likely it'll be similar, but the time part will be insanely better. So it depends, but I know a lot of people, they don't struggle and don't care much. They at one interview, a guy astonished me. He told, I never used a hash map. So it was a senior engineer, and we are kind of a pretty decent company. So when he told I never use a hash map, I was like, okay, this doesn't add more points to your, let's say, engineering karma. Okay, so I guess let me start coding this implementation, getting it in big O of n square. Yeah. So not knowing hash maps as a senior engineer, I don't know. I mean, that's not. It's at least weird. Okay, so let's sort it first. Yeah, let's go with this sort and stable, because it looks like it's faster, and competitive programmers, they do it often. Okay, so we do have this this part done. Next part, I guess we will go number by number. But at the same time, I'll need to remove it. For the two-sum algorithm, I guess I'll have here the two-sum part where I have my nums. I'll write it as a reference, and I'll have a target, and I'll be returning an array of I32s, because I don't need the indexes, I need the numbers in this case. To do. Yeah. Yeah, I wonder why the grass is green and hash maps never seen. Yeah, that's a cool one. You should patent it for sure. Okay, so yeah, we know that our nums will be sorted. I guess I'll just write again what I did do a couple of moments ago. So let's do left will be 0, right will be nums of len -1, while left is less or equal than right. Stand-up comedian, yeah. Yeah, I was thinking to do similar stuff. Actually, when I am invited to present something at our local communities, I did some presentation at the GSM there community. I have like 4 or 5 or even more presentations there, or speeches. And I try different emplois, and the ones which you joke a lot, people like the most, because even if the content is interesting, if your presentation doesn't have humor, it's kind of too dull, unrememberable. So you'll need to include a bit of humor. Okay, so what do we have? Like if nums left plus nums right is strictly greater than target, what do we do in this case? We do, if right is 0, we break. Else we do right minus 1. Yeah, the most memorable one, for sure, yeah. And actually, they do not recall the content in itself. Mostly, they remember the attitude, the feeling, the happy moments, and this is what they recall after the presentation, and maybe some content parts. If you point them again and again, but jokes are mandatory in every speech. Okay, so we have else if. Yeah, I've just solved this two sums problem a couple of moments ago. I'm just writing it again, so exactly the same logic. So we'll have like left plus 1, and else we break, and we will be returning back of nums of left, nums of right. Wait a second, if there is something, yeah, that's a trick. I'll need to check if there is a solution. Yeah, because for this case, it's not necessarily true that we'll have always a solution. I guess. I'll have this flag, this bool flag false at first. Yeah, so yeah, let me write it like solution found. So here I'll do like solution found. True. And if we do have the solution, we'll be returning the solution. Else it will be an empty back. Okay, so this have this I have a feeling that it may work. So we'll do the following part then. Okay, so we'll do the following. Let target will be -1 multiplied by num. So that would be the target. Let solution or potential solution. Okay, so here I'll need like results. So let solution will be solution to some nums and target. But here it's a little bit tricky because I don't want to include my nums. And how can I do that? I guess I'll have it here like iterator enumerate. And this will be like index and num. And here we'll be returning our results. So, so kind of we'll need to remove the current index from num. And how can we do that? I guess the simplest way, we'll have like range nums. I'll have it from, I'll have like two ranges maybe. Yeah, let me do a little bit of research. Rust, remove an item in an iterator. No, retain. No. I want something like concat to back ranges Rust. Is it possible to do that? Oh, so I can do with chain. That's interesting. I can do with chain part. And then collect. Do I need to collect? Yeah, unfortunately I need to collect. And that's expensive, unfortunately. But my idea is to do like nums starting 0, including index. I guess I'll need to iterate. And then I'll do chain. Nums starting index to nums.len. But wait a second, in this case I'll include it 2 times, so I don't need then the first part. Okay, so I'll chain this. This will be like an iterator. And we'll be collecting this as a vec. So this is pretty expensive, unfortunately. And here, I guess I can pass it as a reference. Will it work? Oh, looks like it's working. No, it doesn't. Yeah, maybe I can dereference this and this. So it looks like this is working. So what this stuff does, it will remove from this vector the current item, and I'll pass the remaining to my toSum function. But it's very expensive because imagine this, guys. I'll have my my initial vector here. So let's assume I sorted it. So I'll be sending first this vector, then second one I'll be removing this and sending this vector, and then this vector, and then this vector, and so on till the end. So I'll be using tons of memory to solve this. But this may work. So let's do the following. If solution is empty, then this means we didn't found any solution. So let's go like we don't have an empty solution. Then we'll do results that push back. Yeah, kind of I'll need to, let's do mutable this. No. Yeah, maybe I'll need to put it in first to be first one. Yeah, logically it should be first, but it doesn't really matter, I guess. So results.push solution. And that should be it. What did we get? So we've got a bit more. Oh, so yeah, kind of we'll need to. So we've got our results, which is good thing. But the trouble is we'll need to filter out the distinct ones because it looks like we have too many. So that would be a solution. This one would be a solution, and this one would be a solution. So we have like 3 of them. Okay, so these 2 and this one, so 3 possible solutions. But wait a second, I don't have 2 2s. How did you get 2 2s? Wait, this is not right. Not right at all. Yeah, let me check, as this is not correct. Somehow it got 2 2s, but I don't have 2 of them in my num set. So it looks like they overlapped or something. Okay, so nums, I hate when they do it like this. Wait a second, so -4, 1 and 2. No, something is not right at all. Yeah. Yeah, let me get here. I think like this range part may not work as expected. Wait a second, I think this should not include. Okay, so it doesn't include it. I shouldn't include it. But to be sure, then I should start at index +1. Yeah, that was, I think that was the mistake. So yeah, we still got it. Not sure. Okay, let's play with the debugger. So what would be the target? 4. So I guess num will be -4. So I assume range nums should not contain -4. Indeed it doesn't. Wait, but in this case I feel like I should never have it equal. It should be less always. Because we cannot have it 2 times the same item. Okay, so now it's more on our case. So we have 2 times the same solution, which is kind of obvious. How can we filter them out? because I need some sort of hash set of hash sets or triplets. Because if the order is different, it's already a different vector. Yeah, that's very annoying. How can I clean them? Maybe I should not go with all items. Okay, so if we go with an obvious, like, yeah, we are close to 2 hours, so let's try to finish this one. So yeah, my trouble now is that I have all the solutions, but I need to filter only the distinct ones. So in order to filter out distinct solution, we'll need to use a hash set. But the trouble with the hash set is that I may have the different order for the solutions themselves. So I'll need kind of a different approach. I'll need to find my own sort of hash. I guess the simplest hash would be, because I know it's triplets. But yeah, that's not right. Need some sort of a counter maybe. One way to do it's okay, so I can go like I can count how many minus ones, and I can count the numbers. If I see the same number of counts, I'll be discarding them. Maybe that's a way to go. So yeah, I can go like, but how to store them? I need to store it in sort of a hash set. Yeah, this is too complex. I mean, it's I can solve it, but it will be like a ton of code. And the trouble is, I feel like it should be something easier. Should be something easier. So we've got the solutions. Maybe I shouldn't insert them first. So yeah, at this stage, we will need some sort of hash set to check if it's already there. Hash set to check if it's already there. Yeah, let's try to create some sort of hash set. I don't know, let's call it set for now. Okay, but what exactly should we insert? Can we compare two sets? Okay, so what do we know? Yeah, let's go on the whiteboard a bit. So we have a couple. Yeah, we do have a couple of combinations, which they are similar. Okay, I guess let's use Yeah, wherever this spot will do. So these two are obviously same. I guess this one, and this one. As a human being, how can I understand if they are same or not? I can understand because I have -1 being 2 and 2 being 1. So I have this structure for all of them in different format. So if I have this structure, then maybe I should transform it into a hash set, a hash map, and insert this into a hash set. And that's quite interesting how it will behave, because I have absolute no clue. Because we may have the following, like 2, 1, and -1, 2, which are equal from human perspective, but not from a computer. The computer will not store them in the same order, so they will be different. Wait a second, can we compare? Yeah, let me try. At least let me try. Maybe I'm over complicating it a bit. So let's do the following. If solution, so we have our solution. If a set contains solution, doesn't contain solution, we push in result, and we need to add set insert our solution. So we need to insert it. Yeah, we'll need to clone that. Yeah, I'm not sure about RAM usage, but this will be insane. Okay, so yeah, order, it's... Do I need to sort them? That would be insanely stupid, but I guess a way to do it. Oh my god, that's... that would be like... yeah. That would be like a way to go. I mean, it does solve the problem, but memory and... For the sake of... let me try to push it and see if this works or not. But this... It's unlikely that this will pass. So yeah, let's use, what do we use? A hash set, I think. It's std collections hash set. What else? Oh my god, that's a couple of sorts inside the for loops. Yeah, looks like it's working, and they kind of approved it, but let's submit it. So we do have a wrong answer. Okay, so what did we miss? Okay, this. Okay, so first thing, we have a less results than needed. -3, this looks right to me. One and 3. -4. So this looks right. What's the problem with this one? Yeah, it is, but not in the right order. So probably they needed to be in some specific order. Okay, order of the output and order of the triplets does not matter. But I need to have all solutions. So it looks like I do not pass all solution here. So yeah, let me copy this example and I'll play with the debugger and see where do we have troubles. Because it looks like everything with -1, it's somewhat filtered out. And I don't have zeros. Actually, we have 1 with 0. Yeah, that's a little bit weird. Yeah, let me move on. Okay, so this we don't need. So let's check this one. Okay, so I need a comma here. Let's skip this one. Okay, what else? What else? I feel like that should be it. So I guess for first stage, I am searching for 2 numbers that will give me 1. Okay, so let's go with the debugger and try to identify. So first item, target. Yeah, it looks like this is old stuff. Target -4. Wait a second. Oh, so I do have it sorted. Okay, so let it be -4. Range nums. So it's -3, -2, blah blah blah. Okay, so let's do this. I'll trust it for now. So I've got my solution. 0 and 4. So -4, 0 and 4 should be good. So that's indeed a right solution. It's not there. I'll be pushing. Okay, so let's go next. So we have 3 now. We do my range blah stuff. Range nums, yeah, doesn't contain -3. Solution, so what's the solution? It's -1 and 4. It's a correct solution. It's not there. We insert. Let's move on. Target 2. So now we'll need to find the target 2. -3, -1 and 3. Yeah, but I kind of start to understand why. Because we might have multiple though. And in that case, we'll for -3. So if we check here, so yeah, let's check -4. So 4, we have this, and as well 4, we have this 1, 3. So we have 2 solutions. In my case, I do have this. I do have this. But I need the other ones. So I'll need to find not only one, but I'll need to find all possibilities to have my solution. But how can I do that? So I guess the two-sum algorithm is not right in this case. I need to optimize it a bit. It's getting late on my mind. It's going away. But the trouble is here. We'll need to have a vec of x. And maybe I don't need to break it. Maybe I just need to move on. So instead of this, I'll have like solution, which will be a vec. So here I know for sure that they are equal, so I can do like a solution that push, and I have like vec of nums left and nums right. So I know that that's a solution. Though the trouble is what? Yes, solutions. Trouble is I'll need to move on. So I know that they are equal. But there is a possibility, I'm not sure in what direction, that I have. Wait a second, this doesn't make any sense. Or no? No, actually, yes, it does make sense. I guess I'll just move on. Left plus equal 1 and right minus equal 1. So I'll just move the pointers toward the center. And if I'll find multiple solution, but I'll need to guard against this. And here I'll have like vec of vecs, and for each solutions, let me call them solutions. No, this will not work. Yeah, it's possible that there is no solution. That's fine. Results. Okay, so here I'll do for each solution, for solution, in solutions. First thing we do solution that push num. So we'll be pushing this. Then we'll do our solution that sort. And then we'll do our comparison and insert. Okay, so wait. So vec sort solutions, solution and solution. This needs to be mutable. And this may not be mutable. Okay, so now if we run it, we should have a bit more solutions. Yeah, now looks more like it. Oh my god, that's so ugly. Let's try to run it. I would be very happy if this at least works. Compile error. Oh, I need to include it. And zoom it to... yeah, this hash set stuff. TP collections hash set. Okay, we managed to make it work. So test cases are fine. So now let's try to submit. And if this will be accepted, oh my freaking god, it was accepted. It's insanely stupid and long, but it was accepted. So I'm very happy that it's kind of solved. Cool. So yeah, we are on the bottom of the chain of engineers, so definitely this is not an optimal solution. But it was accepted, so this makes me happy. Now let's check some smart ways on how to solve it. Okay, so still a sorting way to do. Yeah, not sure I have energy to fully grasp what's going on. But overall, it's the same two-pointers technique. Okay, I guess, and this is like 50 times faster than my solution, so which is pretty insane. Well, probably I'll pick this one from. I'll pick this one on the following stream, and I'll check. But yeah, I'm very happy that I managed to solve it. Maybe with a clear mind, I would have come up to something faster and better. Okay, guys, I am done for the day. Let's summarize what we managed. So yeah, I guess I'll need to mark this as completed as well. Resum. So we managed to solve like 4 problems. Yeah, this one and this 3. Which is a pretty good result. And I guess for the next time, we have this like container with most water and trapping rainwater. So yeah, pretty interesting things ahead. Have a nice evening, and probably next stream will be either on Friday or Saturday. I'll try my best to do at least 2 streams this week. So yeah, have a nice evening, guys. Bye bye.